First, draw a good clear diagram. The car has a mass of 1000 kilograms, the caravan 750. The forward force of the engine is 3200 newtons. We have a resistance of 800 newtons. We've got in the tow bar tension, slowing the car down. This tension is driving the caravan forward. We have a resistance force on the caravan. The green force is the mg acting on the car, mg acting on the caravan, and the reaction forces here. Because there's no friction, the green forces have no impact on the horizontal motion. We will look at the whole system. And apply F equals ma. All forces to the right will be positive, all forces to the left will be negative. We have 3, 2, 0, 0, minus 800, minus a t, plus t, minus r will equal the combined masses 1750 times the acceleration, which is 0.88. Now I apply F equals ma to the car or caravan. Tension minus the R will equal the mass times the acceleration. Tension minus 860 will equal 750 upon the 0.88. So the tension will equal 750 times the 0.88, 660, plus the 860, giving a combined total of 1520 newtons. Constant acceleration for 4 seconds, reaching a speed of 5. Constant speed and then a deceleration. Distance run by the gear in the first 64 seconds is the area of a trapezium, which is a half of A plus B times the height. So the two parallel sides are 64 plus 60 multiplied by the height, which will be 5, giving a total distance of 310 meters. If we look at the final part of the journey, it is a 400 meter race. We have already travelled 310 meters in the first 64 seconds, which means the area under this graph has to be 90. Again, we've got a trapezium, so we've got a half of the A plus V, in this case will be 5 plus V times the distance between them, which is 20, has to equal 90. A half of 20 would be 10. 10 upon the 5 plus V will equal 90. 5 plus V will equal 90 divided by 10, which is 9, giving a total V must be 4 meters per second. Marking all the forces, we will have 5 mg acting downwards here. We will have kmg acting down this way. We've got a tension in the string equal and opposite. Because k is less than 5, the pulley will move in this direction. Apply F equals ma to the left hand side. We have 5 mg minus the tension will equal 5 m times the acceleration, which is a quarter g. So the tension will equal 5 mg minus the 5 over 4 mg, and 5 take away 5 over 4 equals 15 over 4 mg. Apply F equals ma to the right hand side. We have tension minus the k mg will equal the mass, which is km, times the acceleration, which is a quarter g. Now we already know the tension is 15 over 4 mg minus kmg will equal a quarter kmg. Cancel out the mg's by dividing right across by mg. We have 15 over 4 will equal k plus a quarter k. So 15 over 4 will equal 5 over 4 times k. Cross multiply, we'll have 15 will equal 5k. So k will equal 15 divided by 5, which equals 3. Part C, state how you've used the information that the pulley is smooth. Simply means the acceleration will be the same for both particles. First, find the distance that A will move to reach the ground. We know that U will equal 0. The acceleration is a quarter g. The distance travelled is what we're trying to find. The time is 1.2 seconds. S will equal ut plus a half of at squared. So S will equal 0 plus a half of the quarter g upon the 1.2 squared. So that's given us a distance of 1.764 meters. Now looking at the diagram, both particles started off above the ground. If particle A moves down 1.764 meters to hit the ground, that means particle B, it started off 1.764 meters above the ground and then moves a further 1.764 meters. So the total distance it is above the ground at the minute will be 1.764 plus the 1.764, which is 3.528. But there's one more stage, because B will start to move under the action of gravity a further distance until it stops at its highest point here. So we must find the extra small distance. Now find the velocity that A hits the ground with. We know U will equal 0. The acceleration is a quarter g. The time it travels is 1.2 seconds. We want to find V. So we'll use V equals U plus AT. V will equal 0 plus the quarter g upon the 1.2. So the velocity will equal 2.94 meters per second. This becomes the initial speed, which with B is going to travel upwards under gravity. So U will equal 2.94 meters per second upwards. At its highest point, the velocity will equal 0. The acceleration due to gravity is 9.8 downwards. We are looking for S, which will be going upwards. Before we use V squared equals U squared plus 2AS, all arrows must be going in the same direction. So we'll change this arrow going upwards and put a minus in front of the acceleration. So 19.6 s will equal 8.6436. So the extruded height will be 0.441 meters, which gives the greatest height will equal to 3.528 plus the 0.441, giving 3.969, which becomes 3.97 meters, correct to three significant figures.